Hello everyone, you are welcome to a series of videos on preparation for Igcse math examination. In the previous series, I discussed transformations, vectors, and functions respectively. In this series, I will discuss circle geometry. But before we start solving the past questions, we need to firstly have a quick revision as usual. So believe me, this is going to be an interesting one. If you are struggling with questions on circle geometry, by the end of this video or the series of videos on circle geometry, I'm 100% sure that it's going to be a thing of the past. Okay, so let's look into something very interesting. So before you could solve questions on circle geometry, so you need to understand parts of a circle, and you should be conversant with some circle theorems, and you should know the steps you should take. Okay, how do you approach questions on circle geometry? So let's look into these diagrams. Okay, so you already know that this is the circumference of a circle, and this is the radius of a circle. This will be the diameter. It is twice the radius. This is the chord. Okay, so a line that touches a circle at 2 points on the circumference. So this will be an arc, that is from point A to point B. Here will be an arc of the circle, and this will be the sector OMN, that is the two radii and the arc, and here we have the segments. Okay, that is PQR, that is this chord combined with this arc make up segments. Okay, so it's very important for you to understand each of these keywords. Okay, now let's go to before we go to the theorems. Okay, so let's quickly look into this approach, how you can approach a particular question. Circle theorems are very interesting, honestly speaking. Once you follow the rules and regulations, then it should be very easy for you. So this is one of the topics my students like a lot. So let's look into the first one. So you need to study the 10 theorems I'm going to discuss with you in this video. So you don't need to memorize them. All you need to do is to recognize them in any given questions. That's the first thing. Then, so watch out other conditions, okay, like parallel lines. So because you can easily get corresponding and alternate angles from there, and you should also mark equal lines or equal sides, okay, if given in the question. Okay, so the third thing you should do is to mark out the angles required. Okay, it could be one, it could be more than one. So just mark them in the given question. So that makes it easier for you to visualize or tells you what to do on time. Okay, and the fourth thing you should do is to check if you can use a theorem to get the value of values directly without any calculation. If it is impossible, then you identify the triangle or the quadrilateral, or basically quadrilateral and triangles. Okay, so where the required angle falls into, okay, that makes the work easy for you. Okay, so these are the steps you should take. So let's look into an example before we go into the theorems. Okay, so this is a question, and you are asked to find the values of P and Q. Okay, so if you want to approach this question, so the first thing is to identify the available theorem or theorems. Okay, so if you look at this now, although you may not understand this now because I'm yet to discuss the theorems with you. Okay, I just want to show you I just want to illustrate those steps. Okay, so for now we have two theorems available here. So the first one will be angles in a semicircle. So this particular one, okay, it is 90 degrees. That is from triangle ABC. Okay, we have angles in a semicircle, and which is 90 degrees. That's the first theorem. So the second theorem will be cyclic quadrilateral. Okay, so if you want to get cyclic quadrilateral, it will be the four vertices of the quadrilateral touching the circumference of the circle. So in this case, we have point A, point C, point D, and point E to be touching the circumference of this circle. Okay, so that means quadrilateral A, C, D, E is a cyclic quadrilateral. And from there, we have two theorems which we are going to discuss later in this video. But the one I want to apply now is that the opposite angles of any cyclic quadrilateral, okay, are supplementary. That is, they add up to 180 degrees. Okay, so that is the first step you should take. Okay, so the second thing is to see if you can use a theorem to get the answer directly. Okay, so we want to get P and Q. Okay, so this is Q, and then P could be got from either this angle or this angle. So there's no need for us to mark it. Okay, so let's say the first one we can get from this theorem now, from this triangle ABC. Okay, so that means triangle point P, or sorry, angle P is inside this triangle. Okay, triangle ABC. So that means we can do something from that triangle. So since we have used a theorem to get the angle of this angle, that is angle ABC, okay, so you should know how to read an angle. You should know how to locate an angle. So this angle is angle ABC. So the angle in question, okay, will always be at the middle, and you put a cap on it. For instance, take for instance, you have ABC. So this is angle B. So we are referring to this one. So if you say angle BAC, you put a cap or caret on it. Okay, so you are referring to angle A, which is 2P. Okay, so this is 2P. So if you say angle ACB, so you are referring to this angle following this other ACB. So that will be equals to 3P. Okay, so you should be able to read this angle. And of course, you may want to say CBA, they are equal. Okay, and here you may want to say CAB instead of BAC. Okay, this and this are equal. This and this are equal. The most important thing is the what is the middle letter. Okay, and here too you may want to write it as BC. Okay, A. So they are also equal. Okay, so this is the first thing you should take note. Okay, so from this now, I know that I have three angles in a triangle, and I know that they add up to 180 degrees. So I can say 2P add 3P, okay, add 90 degrees equals to 180 degrees. Okay, so and if you may want to add these two angles alone, that is, you may want to say 2P plus 3P equals to 90 degrees. Why? These two angles are supplementary angles. That is, they are complementary angles. Why? Because they add up to 90 degrees. So the third angle is already 90. That means these two angles have 90 degrees to share between them. Okay, so if you follow it like this, it will be 5P equals to 90 degrees, and P will be equals to 90 over 5, and that will be 18 degrees. That will be the value of P. And if you want to follow this one by adding the three angles, so this will be 5P add 90 degrees equals to 180 degrees. So if you collect like times, so 5P will be equals to 180 minus 90 degrees. So you still come back to 5P is equals to 90 degrees, and of course P will be equals to 18 degrees. Okay, so you can so you are done with that. So the next one is to find Q. So just like what I told you from the shape ACDE, we have cyclic quadrilateral, and we know that opposite angles of a cyclic quadrilateral add up to 180 degrees, they are supplementary. So that means these two are opposite angles, okay, then they should add up to 180 degrees. So I can say Q plus 5Q should be equals to 180 degrees. Then this should be 6Q to be equals to 180 degrees, and Q should be equals to 180 degrees over 6. And if you do that, you should get 30 degrees. That would be the value of Q. Okay, so this is how you approach a question, okay, in regarding circle geometry. So let's look into the theorems. Okay, this is the first theorem. So I just designed this, okay, for you to understand better, and this will be available in the description and comment sections below this video, so you can always check them. Okay, you see the documents there. Okay, not just this. Okay, the checkup will also be as well be there. Okay, so this is the first theorem. Just like I said earlier when I was telling you the steps you need to take to solve a question, so you don't have to memorize this word for word. Okay, so the only thing you need to do is to be able to identify them in any given question. So this theorem talks about perpendicular bisector of a chord. Okay, so this is called PQ. Okay, so if a line is drawn from the center of the circle, in this case the center is A, okay, and drawn to meet the chord, so definitely it's going to be at right angles like this, 90, and it's going to bisect the chord PQ into two equal halves. Okay, so that means PB is equals to QB, okay, and the angles here, okay, that is angle PBA and QBA are 90 degrees each. Okay, so from there we can say triangles PBA and QBA are what are similar, congruent triangles. Okay, so and here you can use Pythagoras theorem to find the value of an unknown side. Okay, so that is what you need to know in first theorem. You have a perpendicular bisector, then you should know that the chord will be divided into two equal halves, and you can use Pythagoras theorem because you have a right angled triangle. Okay, so you may want to join this and this together like this, something like this. Okay, so these right angles allow you to use Pythagoras theorem on any of the two triangles. So let's go to the second one. You have angles at center, okay, and angles at the circumference. Okay, so there's one thing you should take note. Students used to make a lot of mistakes regarding this. Okay, so the angle at the center and the angle at circumference should come from the same arc, should be produced by the same arc. Okay, so look at this arc now. The arc here is PBQ, that is the arc. Okay, and if you trace this angle at center, which is X, you can see that the base will be here and here. Okay, that is the arc. So also, if you look at the angle at circumference, that is angle Y here, okay, so the base will be P and Q. So these two angles are produced by what? By this arc, okay, PBQ. So you can then see that X is equals to 2 times Y. So that is angles at center and circumference respectively. So you don't need to memorize this, that it says that angle subtended by an arc at the center is twice the angle it subtends at any point on the what? On the circumference. You don't need to memorize that. So once you just have this, okay, so you should know what you should get from it. Okay, and I can also do another thing. I can draw another I can construct another angle, okay, that will have the base to be here. I can do something like this, okay, then this will also be like this. Okay, so if you do this, so this is also an angle at the circumference, and you can see the base is from this arc, so this will be equals to Y. Okay, so as X will also be twice this. Okay, so that is the second one. So the second one will be angle in a semicircle. Okay, So before you can have angle in a semicircle, okay, so you should see the diameter and you should see the center, of course, okay, and you need to be very careful. So the angle that will be in a semicircle should come between the words, between the diameter, like that is, it should come from the two ends of the diameter. Okay, so that is what you should do, because I could construct another angle here now from here. Okay, then let's take another one from here. Okay, so one of the mistakes students used to make is that they will take this to be an angle in a semicircle, so which is wrong. Okay, so before you can, because they will just be carried away for the fact that they've seen diameter and this is at the circumference. Okay, so you should wash out the angle, the base of the angle. So the base of the angle must be produced, okay, by the two ends of the diameter. Okay, so this is not by the other end of this diameter. Okay, so please take note. So this will never be 90 degrees. It can't be. Okay, so angles at the angle in a semicircle will be 90 degrees according to this theorem, and you should watch out for the base once again. So the base must be from the two ends of this diameter. So that's the third one. So you just have to study this very well. You don't need to memorize the theorems. Study this, that okay, when I see angles in a semicircle, what should I do? So I should expect the angle to be 90 degrees, and you should know how to get it. And also, when I see an angle at center, an angle at the circumference, and they are produced from the same arc, so I should know what should happen. That is, the angle at center should be the twice the angle at the circumference. So that is what you need to know. So no need to memorize them. So yeah, angles in the same segment. So angles in the same segment will also come from the same arc, and they will be at the circumference. Okay, so if you look at these three angles now, angles y here, this one, and angle y at point B, and the angle at center. Okay, although they are from this arc PMQ, okay, but only two are in the same segment. That is angle y at point A here, so an angle y at point B here, or you may want to read it in a more in a formal way to be PAQ, that is this angle, and this will be PBQ, that is this angle. So even by writing them down, look at it, PAQ. So you see that the starting point is P and the ending point is Q, that is the base. So the second one, the starting point is P and the ending point is Q, that is the base. So from there, you can see that they are both produced, okay, by the words, by the arc PQ. Okay, so this angle here is not angle in the same segment with these two, because it is not at the circumference, it is at the center. So this angle is twice these two angles here. So this is the fourth one you should know. Okay, so let's go to the next one. That will be the fifth one, opposite angles of a cyclic collateral. So this was the theorem I used when I was illustrating the steps you should take when solving questions involving circle geometry. Okay, so the first thing you should do is your ability to identify a cyclic collateral is very important. Okay, because students from experience used to choose or take a wrong one to be a cyclic collateral. Okay, so we should watch out for the four vertices of the shape of the collateral. So they must be on the circumference, as I said earlier. So this is point A, B, points A, B, Q, and P respectively. They are on the circumference, and you can see that this shape or this collateral is cyclic collateral. So once you confirm that, then the opposite angles, that is N and X, are opposite, so they should add up to 180 degrees, and Y and M are opposite, they should add up to 180 degrees. Okay, so that is one theorem you should know. Okay, another theorem you should know regarding cyclic collateral is the external, which is this. Okay, so the exterior angle of a cyclic collateral. Okay, so if you can see that you have a cyclic collateral before because points A, B, Q, and P are on the circumference of this circle. Okay, and you can see that angle Z there, that is angle BQR. Okay, they produce this external angle or exterior angle. Okay, so once you have that, so the exterior angle, okay, will be equals to what? It will be equals to the opposite interior angle. So the opposite interior angle to Z or Z is this N. So you can say Z is equals to N. So this is another theorem. So if you look at this very well, from cyclic or lateral, you just have two theorems. The first one is that the opposite angles are supplementary, that is, they add up to 180 degrees, and second one is this: the exterior angle is equal to what? To the interior opposite angle. Okay, it's equals to interior opposite angle. So the seventh one is this: when you have equal chords. Okay, so provided that chords MN and PQ are equal, then the distance between the two chords from the center should be equal. Okay, so equal chords are equidistant from the center. So you can say that OA is equals to OB. Okay, so provided that MN is equals to PQ. The next one is theorem 8. So when you have two tangents, okay, so if you have two tangents that meet at a point outside the circle, okay, then the following will happen. Okay, so we know that BQ and then AQ are what? Are tangents. Okay, AQ and then BQ are tangents to this circle. Okay, because they each touch the circumference at a point. Okay, so if this and this are equal, okay, so look at the things you should see here. So if two tangents are drawn, okay, to meet at a point outside the circle, okay, so the two tangents will be equal. Okay, so that is the first thing. You are taking three things here. If two tangents are drawn from a point outside the circle, okay, then their length are equal. So that means AQ will be equals to BQ. That's the first thing. So another thing is that this angle BOQ, that is BOQ, this angle here, I can call it X, and this angle AOQ, this angle here is Y, so I can say they are equal. So that is X equals to Y. So that is the second thing you should take from here. And the last thing you can take from this theorem is that angle BQO, this one again, okay, so will be equals to angle AQO. This one I can say this is M, and I can say this is N. So you can see M is equals to N. So these are the three things you should take away from this theorem. When you have two tangents drawn, okay, to meet at a point outside the circle, okay, these three things will be available. The two tangents will be equal, okay, that's the same length, and then this angle at the center will be bisected, okay, so that means they will be equal, and this angle here will also be bisected, they will be equal. Okay, so you don't need to memorize, just take your time to study the theorems, and you'll be good to go. Okay, so let's take another one. So this will be the ninth one. Okay, angle between a radius and a tangent. So we have a tangent PMQ, and we have a radius which is OM. So the angle between them will be what? 90 degrees, just like a right angle. Okay, so that is one thing you should know. And these two triangles, or these two angles, or these two triangles will be congruent, as their size will be equal. So here PM and then MQ will be equal. Okay, so this one here OP. Okay, so that may not necessarily hold. So let's withdraw that. We should stick to only this one here. Okay, so we are just, so as you can see from this theorem, Okay, so what I want you to take away with you is that these two angles are right angle, okay, and it will always be 90 degrees. So anytime you see a radius and a tangent, so the angle between them will be a right angle, which is 90 degrees. Okay, so the last theorem we're going to discuss before we jump into the first question from Igcse past paper will be angles in alternate segments. Okay, so the angles in a alternate segment is very easy. Okay, so to make it easier for you, I have drawn this image so you can always understand it better. So if you look at this tangent PAQ, and we have a chord here, so this chord CA, okay, so you have an angle here, this particular one here. So this is an angle between a tangent and a chord. Okay, there's another angle again between a tangent and this chord. So look at chord AB and tangent PAQ. Okay, so this angle is between this chord and this tangent. So when you have an angle between a chord and a tangent, okay, so the next thing you should do is to identify the angle that will be in the same. So is to look for the angle that will be in the same in alternate segment. Okay, so let's look into the first one. We have angle PAC. This particular one, PAC, this particular angle is between a tangent and a chord. Okay, so that means the angle that will be in the same segment must have its base to come from this chord, that is from here, should come from here and here. Okay, because this is the chord we are discussing, we are looking into. Okay, so that means this angle and this angle are alternate segments and they will be equal. Okay, so if you look into the second one now, so let me remove this. So you have a chord and a tangent, so the angle between them is this now. Okay, so the angle that will be in the same in alternate segment to this must come from where? Must come from the base of this chord, that is from here and here, and the angle is this. Okay, so that means these two angles are alternate segments. So this is the best way I can explain this to you, and this is the best way you could understand it. Okay, so now we are ready to jump into the first question. The point, this is question 20 from paper 058023 May June 2018. The point A, B, C, D, and E lie on the circumference of the circle. Angle DCE is equals to 47 degrees, and the angle CEA is equals to 85 degrees. Find the values of WX and Y. I was about saying Z. Okay, so to do this now is very simple. Just like what I told you earlier in this video, if you want to approach a question like this, so you have to take some steps. Okay, so the first thing is to inspect the diagram. Okay, so after the inspection, then you can deduce some things. Okay, so we want to find angles X, W, and Y. So this is angle W. There is it here. Angle W is here. So is there a theorem that can give you this answer directly? So you have to check. Okay, so this is inside which diagram, okay, or shape. So this is inside this shape, this quadrilateral A, B, C, D. Okay, so that means we have cyclic quadrilateral, right? So the implication is that angle X and angle W should add up to 180 degrees. That is opposite angles of any cyclic quadrilateral. Okay, is what is opposite angles of any cyclic quadrilateral add up to 180 degrees because they are supplementary. Okay, fine. So that is the point you can take from this inspection. Okay, so if you look at angle, but unfortunately we don't know, we have two unknowns, so we cannot get any one of them at this moment. So if you look into another angle now, which is angle Y, Okay, so there's nothing we can, this angle y is inside this diagram, that is this triangle DC, and let's say this one can be M, this point here, okay, point M. Okay, so we also have two unknowns, right? That is angle X and angle Y, right? So this is what we have here. Okay, so for now, it seems that you are able to deduce something tangible now, okay? But if you look at the given angles, that is 85 and then 47 respectively, so you were given these angles for a reason, okay? So let's start with, inspect the two angles. Angle 47 degrees is inside which shape? Is inside this triangle, okay? So triangle MDC. So, and unfortunately we cannot get any angle from it, okay? Let's check the second one. So the second one is inside two shapes. So that is 85 degrees is inside two shapes. The first one will be AEM, this triangle, and the second one will be this quadrilateral AECB, okay? So that means we have a cyclic quadrilateral. So from there, you can do something here. That is opposite angles of a cyclic quadrilateral are supplementary. That is, they add up to 180 degrees, okay? And that is how to unlock this question. So I can say 85 degrees plus W equals to 180 degrees. And I can get the value of W here. And that will be 180 degrees minus 85 degrees, and the value of W will be equals to 95 degrees. Okay, since you know the value of W, you can see from what you deduced earlier, so you can get X here, right? So X will be added to W. W is 95 equals to 180 degrees, right? So X will be equals to 180 degrees minus 95 degrees, and that will give you 85 degrees. Okay, another thing you should always do is to put the values you have already. So W is 95, so it's good to put it here because it could help you when solving another question. And X equals to 85, so I can put it here too. Okay, good. Now to get the last one, which is angle Y. So angle Y is inside triangle MDC or CDM or DCM, or so you can name it anyhow. Just make sure that you capture the 3 points. Okay, so what you can do here is to add these two together, right? You can always add these two together and you get the value of Y from there. So that is the easiest thing you could do. Okay, so I can say these three angles add up to what? Add up to 180 degrees. So that means Y will be equals to 180. Okay, then minus 47 degrees minus 85 degrees. So if you do this, you should get the value of Y to be equals to 48 degrees. So this is how you solve or you approach a question like this. Okay, so let's look into another question. So that will be question 8. Okay, 8B, not A, because that is on polygon, and we're not discussing that now. So this is the question we want to solve. So this is question 8B of paper 058041, May June 2018. So A, B, C, and D are points on the circumference of the center O. Okay, so you need to be very careful. Students are used to O as the center of a circle. You need to be very careful. You must make sure or ensure that you are told that it is the center. Otherwise, it's going to affect your solution if you are not told that it is the center of the circle. Okay, so DOB is a straight line and angle DAC equals to 58 degrees. Find angle CDB. angle CD, okay, B. So look at this one. This is the angle we want to get, C, D, then B. So the whole angle here will be C, D, then A. So that is the whole angle here, but we only need this one. Okay, so to get this angle, so if you put a letter here, probably let's say X, you may want to do that. Okay, not compulsory. So can you get this angle directly by using a theorem? Which theorem do we have here? Okay, so if you look at this theorem here, okay, if you look at this diagram rather, so you see that CD is this C, then through this arc. Okay, so we have arc CD here. Okay, so and this arc CD produces two angles, which are angles A and B, because the both come from this place, right? So that means these two angles are what? Are angles in the same segment. So if this is 58, so this will also be 58 degrees. Okay, fine. Then there's another thing again. Since we have a diameter, so that should prompt you, okay, to look for what? Angles in what? In a semicircle. So since I have the diameter, okay, so this angle, okay, that the angle at C here, as its base should be from the diameter, that is from the two ends of this diameter. So that means I can say the whole of this, okay, from here to here is 90 degrees. So you can see, so we can get the value of angle X now, which is the required angle CDB. Okay, so let me remove this. Okay, so we know that these three angles add up to what? 180 degrees. Okay, and you may want to remove this one because this one is 90. Okay, so these two angles, okay, are complementary. That is, they add up to 90 degrees because the third angle is already 90. That means they have only 90 degrees to share between them. So that is easier. I can say angle X at 58 degrees is equals to 90 degrees now, okay, because they are complementary. So I can say X equals to 90 minus 58 degrees. So the X should be equals to 32 degrees. So that means the required angle CDB is equals to 32 degrees. Let's go to the next question. So this will be question 9C from paper, okay, I think from the same question from paper 058041 May June 2018. So P, Q, and R are points on the circumference of the circle, center O. PO is parallel to QR and angle POQ equals to 48 degrees. As mentioned earlier in this video, that anytime you have information like this, okay, you should always work with it first. So we have parallel lines, and you know that from parallel lines you could get corresponding angles, alternate angles, and so on and so forth. So if this is 48 degrees, okay, so look at letter Z from P through O, through Q, and through R, that is letter Z. So automatically, so this should be 48 degrees, okay. And if you want to look at it in other way around, that is from O through P through R and then through finally to Q, okay, you see that this angle here, okay, and this angle here, they are also equal, okay. So I can say this and this are equal. So I can put X here. If this is X, so this will also be X, okay. So we want to get angle OPR. Consider even before I started solving the question, okay, by putting the necessary things there is my work, right? It makes my work to be very easy, right? Okay, that is good to do. So find angle OPR. OPR is this angle X here. Okay, so from here I have some I have one theorem, or I can say I have two theorems. Okay, so here we have this angle as center, and we have this angle at circumference. Okay, so because they are produced by this arc PQ, okay, so that means this angle POQ, you may want to write POQ equals to twice, let's say, PRQ, okay. So, and POQ is already 48 degrees, okay. Then this will be 2 into PRQ. Automatically, PRQ, okay, will be equals to 48 divided by 2. That will be 24 degrees. So that is PRQ, which is X here, okay. So, but we are interested in OPR. Since OPR and PRQ are equal, then we can say OPR is also 24 degrees. So this is 24 degrees. So this is how to deal with questions like this. Okay, so let's go to the next one. So this will be 9A from paper 0580 4 to May, June 2018. A, B, C, D, and E lie on the circle center O. So angle AEB is equal to 35 as given, and ODE is equal to 28 degrees, and angle ACD is 109 degrees, 109 degrees. Okay, work out the following angles, giving reasons for your answers. Excuse me. Work out the following angles, giving reasons for your answers. So the first one is angle EBD. Angle EBD, let's see, EBD. So this angle. So from here, it is obvious that it is an angle at the circumference, okay? And if you look at it, so it comes from here, okay, from this arc. So another angle that comes from this arc will be this, okay. So I'm just showing you this, okay. So these two angles are equal, okay. So since EBD is an angle at the circumference, so it should be half of EOD. So it should be half of this, okay. So that means angle EOB, okay. EOD, okay, should be equals to twice EBD, okay, should be twice this angle. So let's see, you can calculate, or you can get this angle EOD from this triangle EOD. So since OD is a radius, so this and this will be equal, and you have an isosceles triangle, so this will also be 28 degrees, okay. So one thing that will make this to be easy for us to get the angle EBD, we can say isosceles triangle, okay, even without getting the answer. So you can write isosceles triangle, okay. Sorry, the reason should be isosceles triangle here. Isosceles triangle, okay, that's one reason. Okay, we're not done, so let's see again, and okay, let's calculate that. So this angle EOD, okay, EOD will be equals to 180 subtract 28 subtract 28, as these three angles add up to 180 degrees. Of course, it will be 180 subtract 56, as these two add up to 56, and finally we'll get our answer to be 124. So that means angle EOD is equal to 124, and it is twice the required angle EBD. So of course, this is going to be half of it, and it's going to be 62. Okay, so we can write here that EBD is equals to 62 degrees, because you have an isosceles triangle here, and angle at center is twice angle at what? At the circumference. So at the circumference. So these are the two things that made it possible for us to circumference. So these are the two reasons we could get the value of angle EBD. So you have to put them there. So this isosceles triangle made it easy for us to get this angle here, and from this angle at center we're able to get the required angle. So those are the reasons. Okay, so work out B E O. So where is B? This is B, and this is E, and this is O. So we want to get this angle here, BEO. So this is interesting. So if you look at BEO, it's inside which shape? So if you look at it very well, it is inside this one here, this triangle AED, okay, because it's one of the angles at these three angles here, okay, but unfortunately there is nothing we can do from there, okay, because we don't have any information regarding these two angles here, okay. So it's also in another shape, so which is not really, look at this, that is this shape like this. Oh, that's from E to O to D to B and come back to E. But unfortunately, there's nothing we can do from that as well. Okay, so this angle is one of the three angles in a cyclic quadrilateral. Let me show you. We have cyclic quadrilateral EACD. Okay, so that is the whole of this angle here. Okay, so it's opposite to this angle here. So we can use that theorem. So that means these three angles, okay, plus this opposite angle should add up to 180 degrees, okay. So I can just scroll down. So I'm going to say 35 plus BEO. So I can call this maybe X, okay, that is the required angle. So I'll call it X. So 35 add X add 28. Add 109 should be equals to 180 degrees. Okay, so let's scroll down. So we can say 35 add X add 28 add 109 to be equals to 180 degrees. Okay, because they are supplementary. So if you do this, 35 add this, okay. So add this, okay, you should get 172. So I can say X add 172 equals to 180 degrees, and X equals to 180 degrees minus 172, and X is obviously 8 degrees. So angle BEO is 8 degrees. So let's go to the next question. So here, question 2 from paper 058022 October November 2018. So the diagram shows a circle, center O. AB and DE are chords of the circle. M is the midpoint of AB and N is the midpoint of DE. AB is equals to DE, that is this chord is equals to this chord. That means you have equal chords. So don't forget that there's a theorem, okay, that says equal chords are equidistant from the center. So M is the midpoint of AB, okay, and the N is the midpoint of DE, okay. So do you know what that means? That means this radius, there's a theorem that says that ON, a line drawn from a center, okay, to meet a chord, okay, bisect it, okay. So that's the implication, okay, just to draw attention to that, okay. So M is the midpoint of AB and N is the midpoint of DE. AB is equals to DE, okay, the two chords are equal and the value is 9 centimeters, okay. So and OM is equals to 5 centimeters, so 5 is here, okay. So if this is 9 centimeters, that means BM will be, let's say 4.5. I'm just showing you this, okay. So 4.5, and maybe you want to do complete for another reason, okay. In case of next time, you can always construct this, okay, to have something like this. It's pretty easy. So you can always have something like this, okay, then you have something like this as well. Okay, so you can see that we have right angles, so 4 of them there. Okay, so find ON. So ON is equals to OM. Okay, so that will just be 5 centimeters. Why? Because we have two equal chords AB and DE. Okay, so from the theorem, okay, so equal chords are equidistant from the center. So the center is center O. So from O to this chord AB is 5 automatically. So from O to this chord DE should also be 5 centimeters. So that is how to approach that question. Okay, so let's go to the next question. So that will be question 7. Okay, so from paper 058042 to October November 2018. I think after this we have just only one question left, and that will be the end of the video. Okay, so in the diagram, A, B, C, and D lie on the circle center O. EA is a tangent to the circle at A. Angle EAB is equals to 61 degrees, and the angle BAC equals to 55 degrees. Okay, so find angle BAO. Okay, so if you want to approach this, is very simple. So as usual, let's mark the required angle BAO. BAO, that is this small angle from here now. Okay, so how would you get this angle? So if you look at it, it's inside this diagram here. Okay, that's one thing, and there's nothing we can do from there. Okay, because we don't have this and this. Okay, these two angles, we don't have them. If you look at this again, is between this tangent and this radius. Okay, so that means these two angles must add up to 90 degrees from the tangent to this radius. Okay, and we already know that this one is 61 degrees. Okay, so it will be very easy for us to get BAO, because BAO will be the remaining part. So we can say BAO to be equals to 90 degrees. So that's the total angle there, minus 61 degrees, and that will give us 29 degrees. So that's the value of BAO. Let's scroll down and write 29 degrees here. So the next thing is to get angle AOC. Okay, so let's go to the diagram AOC. So AOC will be this one here. Sorry, no, not this. AOC will be, excuse me, AOC will be this one here. That is AOC. So before you can get AOC, you must get these two angles. Okay, and look at this example. We don't have a circumlateral here because points A, D, and C are only on the circumference. Look at point O, is not on the circumference, so we cannot take this as cyclic quadrilateral. So you need to be very careful. So to get AOC, we need to find the base angles of this isosceles triangle, because these and these are equal. So they are both radii, so we have isosceles triangle. So how can we get this angle here, this small one? So I can call this X and call this one 2X to ease my work. So I know that the whole of this angle here is 55. Okay, and I think I got this small one here. This is 29 degrees, right? So from here you can get this. You can see the reason I said you should be putting any value you calculated into the right spot. Okay, so it is your work. Okay, so from there you can get the value of X. So I can write here X equals to the total angle there is 55 minus 29. So the value of angle X will be equals to 20. Let's see, that should be 26. Yes, it should be 26. So let's confirm that this and this add up to 46 and 9. Okay, that's 15. So 55. So X equals to 26. So if X equals to 26, that means this place is 26 and this place too will also be 26. So I can find AOC now. So AOC and these two base angles of this isosceles triangle add up to 180 degrees. So I can just go down and say AOC equals to 180 degrees minus 26 minus 26. So that would be 180 minus 52, and the final answer should be 128 degrees. So I have 128 degrees. So finally we have to find semi-finally. Okay, so ABC, 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 ABC. So this is the required angle. Okay, so to get this angle ABC, so we have two options. This angle and this angle are supplementary because they are opposite angles of a cyclic quadrilateral ABCD. Okay, but we don't have any value here, so we cannot use this one. Okay, so the second thing we could use is that this angle, okay, comes from this arc or this chord AC. Okay, so it's from there, and we know that the angle between this chord AC and this tangent, okay, this one here, okay, so will be alternate, will be equal to this angle in alternate segment. That means this will be angle Y, so this will be Y. So the theorem there is alternate segments that I explained earlier in this video. So the only thing we need to do is to find Y from here. So angles on a straight line add up to what? 180 degrees. So we can say 180 degrees, okay, minus 61 minus 55, okay, will give me the value of Y. So let's write Y equals to 180 minus 61 minus 55. So that would be 64. Y is equals to 64 degrees. So if Y equals to 64 degrees, then the angle ABC is also 54 degrees because they are angles in alternate segments. Okay, so let's scroll down here and write 64 degrees here. Finally, find angle CDA. Angle CDA will be this angle. Okay, so of course that is pretty easy for us. So these two angles are supplementary because they are opposite angles of a cyclic quadrilateral, so they add up to 180 degrees. So I can say that angle will be 61, okay, plus 55, okay. So that will be equals to, okay, let's see, let's check. Okay, sorry. So these two angles, they are supplementary. Okay, so that means it should be 180 minus 54 if we want to get this particular angle here. Sorry, I think I made a mistake here. So the value of Y is 64, so not 54 here. So let's correct that. So it's 64. So this place will be 64, not 54. Let me check. Okay, I wrote 64 there. So now, so to get this angle was CDA, okay, CDA. So this and this are opposite angles of a cyclic quadrilateral. So they add up to 180 degrees. So I can say CDA will be equals to 180 minus 64. So this should give us 116. Okay, so that is one way. So another way you could get this is to look at this angle. Let me erase this. Okay, if you look at this angle here, okay, so is cyclic quadrilateral, is alternate segment to this one here. Let me show you. So I have to remove this. So you see that this angle, let me mark it very well, this particular one, and this angle that is from here to here. Okay, look at chord AC. Okay, so the angle between chord AC and this tangent is this one. That is the addition of 61 and 55. So it's in alternate segment. So this angle here is alternate segment to this. So I can put M here. So that means the required angle, which is M, will be equals to what? Addition of 61 and 55. So if you say 61 add 55, you should still get 116. So there are many ways you could always get your answer. So So it depends on what you can see there. So I'll write 116 as my final answer here. Okay, so let's go to the last question, and that will be the end of this video. So here you're asked to find V, W, X, Y, V, W, X, and Y from this diagram. Okay, so if you look at this very well, so let's start with V. So V is inside this triangle TOP, but unfortunately we don't have the given two angles here, so we can't find V. But also, if you look at it very well, V is equals to angle at center, okay, because it comes from this arc TP, okay. So and there is angle at circumference that also comes from this TP, which is this one now, okay. So that means I can say V is equals to, that's angle at center is twice angle at the circumference, 75 degrees. Don't forget, the angle at center and the angle at circumference must always come from the same arc, okay. So that's how to get it. So V is equals to 150 degrees. So I can put 150 here. So since this place is 150 degrees, so I can get this place. This place will be 30 degrees. Why? Because these two angles are on a straight line and they add up to 180 degrees. So if you look at this angle, okay, and this angle, okay, so they are produced by this arc, okay, only that this one is at the center while this one is at the circumference. So I can say this 30 now, okay, the one at the center should be twice x, okay. So that means x equals to 15 degrees, okay. So this is one way of getting your x, okay. So if you see another approach there, you can use it. There are many ways of solving it, okay. So I'm just using the one I can see here, but you may see a different one. Provided you follow the rules and regulations, we'll still get the same thing. So the next one is W, okay. Look at angle W. So from this triangle, okay, that means it comes from this arc PQ as well. So that means this angle X here, okay, and this angle W here, they are angles in the same segment. So you can say W is equals to X. So that means W is equals to 15. So straight away, and you may want to say, okay, this is angle at circumference, this angle at center. So 30 will be twice W. So it's still the same. Okay, the last one is angle, which one do you have left? Angle Y. So where is angle Y? Okay, angle Y is here. So let me remove this for you to see. So angle Y is here. So you can easily get this angle. Once you get this angle, then this angle plus angle V plus angle Y will be 180 degrees. So let's get this angle. So this angle is vertically opposite to this, and vertically opposite angles are equal, okay. So we can just calculate that. So if you add these two together, that is 85 add 75, okay, so this will be 10 0 and this will be 16 160. So that means this place will be 20. So this place will also be 20. So we know that angle V is equals to 150, okay. So that means angle V 150 add this 20, that will be 170. So angle Y plus 170, that is sum of these two angles, okay, is 170, then equals to 180 degrees, okay. Then Y is equals to 180 degrees minus 170 degrees. Y is equals to 10 degrees. So that's the value of Y. So this will be the end of this video, okay. So watch out for, and it is part 1, so watch out for part 2. So as I told you earlier, if you really follow this video very well, so as a student or as a teacher, you shouldn't have any problem with questions regarding circle geometry, and just practice very well and you'll be good to go. So until we meet again in part 2, have a wonderful day and enjoy yourselves.